In this section, we will look at right triangle trigonometry, which deals with the ratios of the sides in a right triangle. We often look at angles in the standard position, where one ray is along the x-axis and the other angle extends into the first quadrant. We refer to the angle as theta. This is the Greek letter theta. The 6 ratios of side lengths in a right triangle are the 6 trigonometric functions. You may have heard of the mnemonic SOHCAHTOA. This will help you remember the ratios. We have, for the sine is opposite over hypotenuse. Cosine, for the is adjacent over hypotenuse. And tangent is opposite over adjacent. Evaluating trig functions can be done on a calculator, but there are 2 special triangles that can be solved geometrically. The first one is the 45-degree right triangle. In all 45-degree right triangles, we have 90 degrees in the corner and the 2 45s, making it an isosceles right triangle. And the ratio of the sides, the hypotenuse will be the square root of 2, and the 2 legs will be both 1. So finding all 6 trig functions, we've got sine on the SOHCAHTOA. Sine is opposite over the hypotenuse. So we go the 45 degrees, we go opposite, which is 1 over the hypotenuse, which is the square root of 2. We don't want to leave the square root of 2 in the bottom, so we need to multiply top and bottom by the square root of 2, so we get the square root of 2 over 2. Cosine. Cosine, so is the which is the adjacent over the hypotenuse. Let's go with a different color here. So the adjacent is the angle right next to it over the hypotenuse, square root of 2, and again, rationalizing, we will end up with a square root of 2 over 2. So sine and cosine have the same, they are the same on a 45-degree right triangle. Tangent is SOHCAHTOA opposite over adjacent. It's the opposite over the adjacent, which is 1 over 1 or 1. The other 3 are the reciprocals of these. So for the reciprocals, we get the cosecant, and all of these should be a sine of 45, cosine of 45 degrees, tan of 45 degrees, cosecant of 45 degrees will be the reciprocal of 1 over the square root of 2, which is the square root of 2 over 1, or the square root of 2. The secant of 45 degrees is the reciprocal of the cosine, and again will be the square root of 2. And reciprocal of tangent is the cotangent of 45 degrees is 1 over 1, which is 1. The second special triangle is the 30, 60, 90 triangle. So let's take a look at evaluating for the 60-degree angle. So the sine of 60 degrees, sine, which is the opposite over hypotenuse, we go 60, the opposite of the 60 over the hypotenuse is a square root of 3 over 2. Cosine of 60 degrees, so adjacent over hypotenuse, which is next to the 60 is 1 over the hypotenuse is 2, so it's 1/2. And the tangent of 60 degrees. That's the TOA, which is the opposite over the adjacent. Opposite of 60 is the square root of 3. And adjacent, oops, that's a 3. Adjacent is 1. So square root of 3 over 1 or the square root of 3. And to get the other 3 signs for the cosecant of 60 degrees, it's going to be, we flip it over, 2 over the square root of 3. And rationalizing that, we get 2 root 3 over 3. The secant, 60 degrees, is the reciprocal of 1/2 or 2. And the cotangent of 60 degrees is the reciprocal of 1 over, the reciprocal of the root 3, which is 1 over root 3, and rationalizing that, we get root 3 over 3. I want to take a few minutes to look at some common calculator errors when evaluating trig functions. To begin with, in the calculator, we have to make sure we're in the correct mode. Remember last chapter we started talking about degrees and radians. Well, the calculator has modes for both degrees and radians. So if you go to mode, you'll see we've got radian and degrees. So you have to be very careful that you're in the correct mode for whichever problem you're working at. Moving down the calculator a little bit, we have the inverse function. We have the sine, cosine, and tangent. And above those, we've got the sine to the -1, cosine to the -1, tangent to the -1. Remember that sine, cosine, and tangent are functions. So the exponent on the function doesn't mean the reciprocal. On the function, it means the inverse function. So sine to the -1 does not mean 1 over sine or cosine or cosecant. The sine over tangent, tan to the -1 there, does not mean 1 over tan or the cotangent. We'll be getting into the inverse functions a little bit later. Another thing to be careful about with the calculator is when we are writing out trig functions, if we want sine cubed of theta plus cosine cubed of theta, this is a shorthand that we would write it out. Unfortunately, the calculator doesn't recognize that, and what you have to do is to write it all out with lots of parentheses. So this would be, that's a sine of theta, close the parentheses, and then that whole thing is cubed, plus cosine in the parentheses of theta, and that whole thing is cubed. So with the trigonometric functions, we need a lot more parentheses, and we'll get into that a little bit later when we are looking at those trig functions to the powers. And which leads me to the last one. You have to be very, very careful about closing the parentheses. The same way we have to be careful about closing parentheses in fractions, in the numerator and the denominator. You have to be careful with your trigonometric functions. Now we're going to look at solving a right triangle. If we have a right triangle with side length 6 that includes a 27-degree angle adjacent to the side of length 6, find the measure of the other two angles and the lengths of the other two sides. So in our triangle, we have a 90-degree angle, we have a 27-degree angle. So we have, to get our third angle, we take 180 minus 90 minus 27, which gives us 63 degrees there. Now we want to use trig functions to find the other sides. We can find trig functions of 27 degrees or of 63 degrees. Either one will work. However, it's generally safer to do it from the given angle, just in case you made a mistake on the 63 degrees. So with a given angle, we want to find C. So C is the hypotenuse. For 27 degrees, this is the adjacent. So we have the adjacent and the hypotenuse. So the adjacent over the hypotenuse gives us the cosine. So cosine of 27 degrees equals the adjacent over the hypotenuse, which is 6 over c. Then we get the calculator. When you're in the calculator, the first thing you need to do is to make sure you're in the correct mode. We are dealing with degrees, so we need to make sure on the mode that we are in degrees. By default, the calculator is in radians, so you need to come down to radians, over to degree, and hit enter. Once you're in degrees, then we can solve that equation. We're looking for the cosine of 27 degrees, cosine of 27, enter, and we get 0.891. Cosine of 27 is 0.891 is equal to 6 over c. So we'll multiply by c. 0.891c is equal to 6, and then c is equal to 6 divided by 0.891, which is approximately 6.73. And there's our length for c. The next thing we want to do is find our b. B is if we're going from the 27 degrees, it is the opposite. So we have the opposite and the adjacent, which will give us the tangent. Tangent is the opposite of over adjacent. So tangent of 27 degrees is the opposite, which is b over the adjacent, b over 6. We find the tangent of 27 degrees, which is approximately 0.51 equals b over 6. Multiply both sides by 6, and we get b is approximately 3.06. When you're dealing with trigonometry, you want to keep the longer numbers in your calculator as long as possible. By rounding here, I'm actually getting a more inaccurate answer. So if you just put the tan 27 degrees into the calculator and multiply it by 6, you'll get a much more accurate answer. And now, just for fun, see you in class.